Hand augering is a technique that is best suited for unconsolidated soils to depths of 15 meters. It is often used to drill the starting hole when using other drilling techniques. Hand augering uses different drilling bits, depending on the type of soil. Once the bit is full, the entire drilling stem is removed from the hole and the bit is emptied. When the water table is reached, the casing must be installed. When the wells are drilled in fine sand, a polyester filter cloth is used to cover the slotted portion of the casing to prevent fine sand from entering the well. The filter cloth is attached using galvanized wire. After preparing the well screen, the casing is assembled and placed in the hole. From this point onward, the drilling is done inside the casing, and the well drillers work on a platform attached to the casing. They use a special bit, called a baler, that has a flap valve in the bottom to remove the sand from the well. Water is added to the well to create a slurry to make drilling easier. Drilling continues using an up and down motion to force the sand into the baler. The casing descends into the aquifer under the weight of the well drillers. When the baler is full, it is removed from the casing and emptied. As the casing descends into the aquifer, additional lengths of casing are added, and the well drillers attach the platforms again. Working on the platform and using the baler with additional extensions for the drilling stem, the drilling continues. Each time that the baler gets full, the drilling stem must be removed and the baler emptied. When the top of the casing reaches ground level, another section is added and the process continues until the desired depth is reached. In order to seal the open bottom end of the casing, a polyester cloth bag filled with sand, gravel, and cement is prepared. The sack is placed inside the casing and then tamped in place to ensure that it will completely seal the end of the casing. Once the well is completed, the finished depth is measured and recorded. Then the well is developed by pumping at a high rate. This cleans out the well, improves the permeability of the aquifer around the well, and also provides an indication of the discharge capacity of the well. After the work is completed, it is time to move on to the next site. Because of the light weight of the tools, they are often transported by ox cart. Rotosludge is a method that is suitable for up to about 30 meters and is best suited for clay soils. It uses circulating water to remove the cuttings from the well. The cuttings flow up the hollow drill stem and are directed into the settling basin by the operator. The tools for the rotosludge can be made locally from 2-inch diameter galvanized pipe. The first section of the drill stem is weighted by welding pieces of reinforcing steel to the outside of the pipe. This increases the effectiveness of the drilling, especially at shallow depths. The drill bit is made from pipe, with sharpened cutting teeth made from truck leaf spring. The teeth cut the soil, and the hollow center allows the cuttings to flow up and out of the pipe. The site must be prepared in order to use the rotosludge method for drilling. This includes installing the supports for the lever, digging the reservoir, drilling the starting hole, and preparing the drilling mud. In sandy soils, a metal casing is used to prevent the hole from collapsing when the drilling stem touches the walls of the hole. A reservoir is dug to hold the drilling fluid and to provide a place for the cuttings to settle. To prevent the loss of the drilling fluid in sandy soils, a tarp is placed in the reservoir. Once the setup is complete, the reservoir is filled with a mixture of water and cow manure to make up the drilling fluid. The cow manure helps to seal the walls of the hole to prevent water loss and the subsequent collapse of the hole. After the reservoir and the hole are filled with drilling fluid, the drilling can begin. The drill bit is attached to the first section of the drill stem and is lowered into the hole. Additional sections of the drill stem are attached in order to reach the bottom of the starting hole that was drilled with the augers. The up and down motion of the drill pumps the cuttings out of the hole. The turning motion increases the cutting power and speeds the progress through the formation. The operator controls the flow of the drilling fluid with his hand. As the hole is drilled deeper, additional sections of drilling stem are added until the desired depth is reached. Like rotosludge, jetting uses circulating water to remove the cuttings from the hole. It is suitable for depths of up to 60 meters. Jetting requires a reservoir for the drilling fluid and, of course, a lot of water. The bit has teeth to cut into the soil and a hollow core to direct the water jet into the bottom of the hole. A special elbow at the top of the drilling stem prevents the hose from kinking and allows the drillers to rotate the drill stem. As is the case with many of the techniques, it is often easier to auger a starting hole. Once the starting hole has been completed and the equipment assembled, the jetting tools are placed into the hole and the hose is connected to the motorized pump. The handle is attached, the motorized pump is started, and the drilling can begin. Once the water starts to flow out of the hole, the well drillers begin drilling using a combination of rotary and up and down motions to drill deeper into the ground. As the hole gets deeper, additional sections of drilling stem are added until the desired depth is reached. Once the work is completed, the well drillers move to the next site. Percussion drilling is a method that is versatile and can penetrate a wide variety of formations, but it is labor-intensive and often slower than other techniques. It alternates between the use of a heavy chisel bit to break up the formation and a baler to remove the cuttings. It does not use a drill stem, but rather a rope. For this reason, it is known as cable tool drilling. In percussion drilling, the idea is to always have mud at the bottom of the hole, so water is added to the hole mixing with the cuttings to form mud. This seals the walls and makes it easier for the baler to bring the cuttings to the surface. The drilling jar makes it easier to change between the baler and the cutting bit, and also provides the means to jar loose a stuck bit. By alternating between the chisel bit and the baler, percussion drilling can drill through hard formations to depths of 50 meters or more. It is often used in combination with other methods to break through hard formations that cannot be penetrated with other tools. By adding manual drilling to our arsenal of techniques to provide safe water for rural populations, perhaps we will see a new dawn in Africa, where the majority of people living in rural areas will have access to clean water.